Okay, we're going to be starting chapter 5 now. This chapter is about random variables. We'll get into what those are in here in just a little bit. We're going to verify that the probability distribution is valid. We're going to calculate probabilities involving discrete random variables. And we're going to classify those random variables as discrete or continuous. Later on we'll talk more about continuous, but we're just going to classify them first. Suppose you toss a coin 3 times. This is the sample space you could have. You got heads, heads, tails, etc. There are 8 different outcomes, and all are equally likely. Okay, so we're going to have this random variable. We'll call this random variable x. You could use any letter, but we'll call it x. X is the number of heads obtained in 3 tosses. Okay, so we define the random variable as the number of heads in 3 tosses. So this is our distribution of that. Okay, so we could have 0 heads, or 1 head, or 2 heads, or 3 heads if we're tossing it 3 times. If you look at our sample space, the probability of having no heads would be tails, tails, tails. 1 heads would be here, or here, or here. 2 heads, there, there, there. And all 3 heads would be that possibility. Okay, so this is a probability distribution of x, of that random variable x. So a random variable can take on, okay, so this is the definition of what a random variable is. It's when these are numbers up here, okay? So a random variable takes numerical values that describe the outcome of a chance process. So the outcomes, these are all the different outcomes, and they're numbered outcomes. That's what a random variable is. Then the probability distribution has all the outcomes with their probabilities with it. Okay, we've kind of looked at those before. Different types of random variables, there's discrete versus continuous, and we'll talk more about those a little bit later. Okay, discrete random variables. That was an example of a discrete random variable, but it takes on fixed set of possible values with gaps between. So you had a 0 or a 1 or a 2 or a 3. You couldn't have like a 0.284. Right? You couldn't have any of those values up here for your x, for the number of heads. That's what a discrete is. Okay, so discrete distribution, probability distribution, you have all these values and you have all their probabilities. You know that all probabilities have to be between 0 and 1, so you can't have any negative numbers or like a probability of 2 for any of these. And you know that if these are all the outcomes, you know the probabilities have to add to be 1. Okay, and that happened here. If you add all these up together, you get 8/8, which is 1. Okay, so this is kind of interesting. The APGAR test for babies when they're first born, they come out of their mother, and they're given a score right away. So a little bit background. In 1952, Dr. Virginia APGAR suggested 5 criteria for measuring a baby's health at birth: their skin color, their heart rate, their muscle tone, their breathing, and response when stimulated. So they kind of spank them a little bit or whatever, just to get a stimulation from them. She developed a 0, 1, and 2 scale for each of those 5 criteria. So if there's 5 things and the max is 2, the max is a 10, right? Highest score for a baby. And their APGAR score is the sum of all the 5, so it can go from 0 to 10. APGAR scores are still used today to evaluate the health of newborns, although this procedure was later named for Dr. APGAR. Okay, appearance, pulse, grimace, activity, and respiration. So they kind of changed it around in honor of the doctor. So what APGAR scores are typical? To find out, researchers recorded the APGAR scores of more than 2 million babies 1 year, and this is our random variable x is the APGAR score of a randomly selected baby 1 minute after birth. Okay, so you could have a scale from 0 all the way up through 10, and these are the different distributions of those kids. Okay, show that it is valid. Okay, so 2 things we have to look for: all these numbers are between 0 and 1. Okay, so all these probabilities are valid. And then the second thing is you have to add all these up together, and if you add them all up together, it does equal 1. Okay, so it's a valid probability distribution. Okay, so finding different probabilities for discrete random variables, we've kind of already did this a little bit, But if these are the number of heads again, x is the number of heads, so we have this distribution. If I want to know x is greater than or equal to 1, okay, that means that the number of heads are greater than or equal to 1. So you could do it two different ways. You could greater than or equal to 1, you could add 1 plus 2 plus 3, right? If you add all those three together, you get 7/8. Or last chapter we also thought about to find these, I could take 1 minus this one, right? So 1 minus 1/8 gives you 7/8. So two different ways to do that there. Okay, here's a problem for us. Okay, these are the APGAR scores again. What's the probability that doctors decided the APGAR scores of 7 or higher indicate a healthy baby. So if you have a 7 or higher, you're healthy. What's the probability that this selected baby is healthy? So 7 or higher, we would write it as x is greater than or equal to 7. Okay, so that's how we find that there. That's the notation we use. Greater than or equal to 7 would be 7, 8, 9, and 10. So we add all these together, and you get a 0.908 probability that the baby's going to be healthy. Okay. Okay, now be careful like with these signs. Okay, we said greater than or equal to 7. Sometimes you just put greater than 7 as well. Okay, and actually for this one, would these be the same? Okay, would those two things be the same thing? Greater than or equal to 7 would be 7, 8, 9, and 10, right? And greater than 6 doesn't include the 6, it includes 7, 8, 9, and 10, okay? Since it's discrete, there's no numbers between 6 and 7, right? So both of these two probabilities would be the same thing, okay? So just be careful with the greater than, less than thing. Now the other type of random variable is called a continuous random variable. So say I want you to randomly select a number between 0 and 1, allowing any number between 0 and 1 as an outcome. So that could be an outcome, that could be an outcome. There's really an infinite number of outcomes there could be that are numbers between 0 and 1. The sample space is the entire interval between 0 and 1. If we define y as the outcome of the random variable, y is a continuous random variable. So the discrete, it has to be certain numbers, a 1, a 2, a 3, or 4, whereas a continuous could be any number within the range. Okay, so there's an infinite number kind of thing as continuous. So in 5.5 we'll deal with specifically the normal distribution, but for now we're just going to want you to decide whether it's continuous or discrete. Okay, most discrete random variables result from counting something, like the number of siblings that a randomly selected student has. Continuous random variables typically result from measuring something, like the height or the time of running a mile, or the randomly selected student. Okay, so I want you to classify these. Okay, the foot length of a randomly selected student at your school, the number of gas pumps out of 12 used, and the string tension of a racket. Okay, so if you think about this, is it going to be a certain number, or is it an interval? Okay, so foot length would be a continuous random variable, because really your foot length could be 1.1256 inches or whatever, or that sort of thing. Now if you're talking about shoe size would be discrete, because it's either you're as 8 and 8.5 and 9 and 9.5, right? That would be discrete. But the foot length, your actual foot size, right? I mean measurement, could be any number at all. Number of gas pumps out of 12. Okay, so it's either going to be 1 or 2 or 3 all the way up through 12, right? So that's a discrete. Okay, it's a certain number that it could be. The string tension. Okay, the tension means how tight these things are, and that's measured in, I don't know, pounds, I guess. Okay, so it could be it's a continuous. It could be 5 point. Actually, I don't really know much about tennis strings, but 50 to 70. So 5.7. Okay, like that, so it could be a continuous sort of thing. Okay, so if you're looking at this last example here, Indiana University Bloomington posts the grade distribution for its courses online. In a recent semester of a business statistics course, that percent got A's, that percent B's, C's, D's, and F's. If we just choose a business person at random, okay, now, so what makes this discrete is we're assigning this on the GPA scale. So a 4 for an A, a 3 for a B, C, D, and F. Okay, so if I just had A, B, C, D, and F up here, that would not be a random variable because we have to have numbered numbers up here. But since we put it on a GPA scale, 4-point scale, we got A, B, C, D, and F. Okay, so is it discrete or continuous? It is discrete because we can't have a 4. And if you take a single class, you're not going to get a 3.8954, right? It's either you fit in one of these categories. Okay, so it's valid. Okay, they're all between 0 and 1, and if you add them all up together, they equal 1. So we have all of our outcomes there. Okay, what does this mean? X is greater than or equal to 3. Okay, we said X was their score, right? Okay, so a 3 or greater would be a B if a student got a B or an A, right? And you find that by adding those two together. 0.362 plus 0.457, 0.819. So almost 82% of the people got A's and B's. Write the event student got a grade worse than a C. Okay, so a C would be a 2, and we want worse than that. So we want the probability that X is going to be less than, okay, X is less than a 2. Okay, or you could also write it as less than or equal to 1. So you got 1, okay, 1 or 0. Okay, so these are what we learned today. Is it valid or not? How do you find those probabilities like this one? You can just add them together. And random variable, discrete or continuous? Is it a numbered thing here, or is it continuous where it could be any number between any of those numbers as well? Okay.